Hello and welcome back to Professional Tutors. So at Professional Tutors, we have a unique team of head of departments who came together to deliver quality education to our learners across the UK and the worldwide. In today's lesson, we're looking at convection. In last lesson, we looked at how does conduction takes place in solid. And today's lesson, we're going to look at how does convection takes place in liquids and gases. So all these two processes, conduction and convection, and there's another one which is called radiation, which we're going to look at in the next lesson. These are three ways in which the heat energy is transferred from a warmer area to a cooler area. So first of all, just have a look at how does convection occurs in liquids. Now let's take an example of water here. So if you look at this example here, there is a heat source or the heating element at the bottom of the kettle. Now as we turn on the kettle, the heating element here at the bottom, it warms the water. Now as the water is heated, it expands, and then it becomes less dense. And as the water becomes less dense, it rises up. Now, on the top, we've got cold water. The cold water is more dense. Now, because it's more dense, it falls down at the bottom of the kettle. And that just takes this is just to replace the water, the warm water, which has risen up. And that creates circular movement of water, what we call convection current. Now this process continues up until all the water in the kettle reaches the boiling point. Now that is how the convection takes place in liquids. Now the main difference we need to remember for the exams is that in conduction, the particles, they don't actually move. They simply vibrate along a fixed position. In convection, the particles, they actually move. They gain the thermal energy or the heat energy. They become less dense and they rises up. And on the top, where it's a bit colder, the particles, they are more dense and they fall to the bottom of the kettle. And that is how the convection takes place. So remember in exams, conduction, the particles, they don't move, they just simply vibrate along a fixed position. In convection, the particles, they actually move. Now, if we move on, let's have a look at how does convection occurs in gases. Now, it is often very windy when we go to a seaside. Let's have a look, why is that? Now, there's always a difference between the temperature of water and the land, and that is because of the difference in specific heat capacity of the water there and the land or the sand. So let's see what's going to happen. Now, during daytime, the land is warmer than the water. So because of that temperature difference, the heat of the land warms the air around or above the land. And as the air becomes warmer, again, it's the same principle. The warmer air expands, it becomes less dense, and it rises up. And that creates a sort of like vacuum here or an empty space. Now the cold air from the sea rushes to replace the space or replace the air, replace the warmer air, which is risen up. Now that sets a circular motion again. It's exactly the same what we have discussed in previous slide, that how the water is boiled, how the convection currents are set in water. It's the same process. And due to the temperature difference, that's again, this sets up a circular movement of air, what you call convection current. and that creates the breeze or the wind at the seaside. Now, it's very interesting to know what happens during night. Now, it's exactly the same process, but just the other way around this time. During night or at night, the land becomes cooler than the sea. And because the water here is warmer, that warms the air just above the water. And as the air gets heated up, same process again, it becomes less dense, it expands, it rises up, and the cooler air from the land rushes to replace this space or replace the place of the air, which is of the warmer air, which has just risen up. And that again, in turns, creates the circular movement, again, what you call convection current. So it's windy at the seaside during daytime and nighttime. The main thing to remember here, the direction of wind is just the opposite during these two different times of the day. And that's all for today. Stay connected. Please like and subscribe for our future videos.